saying I'm nothing to do with the leather industry whatsoever, apart from the way that you can see here. I actually represent Fujifilm, which is a graphics art company, but we're more than that. So I've got to do the corporate bit first of all. Okay, just a little bit about who we are. We are obviously a global company, a well-known brand, but we're actually quite a small company by comparison to our competitors, people like HP and such. We're about a quarter of the size. What makes us slightly different to our competitors, though, is our big investment in R&D. As you can see here, about $7 million per day on R&D across the world. So it's a very, very large investment, and I feel very privileged to work for a company that values technology that much. However, that $7 million doesn't come to me. I'm a very, very small part of it. Okay, as you can see, we work in a very large number of industries. Some that people will recognise Fujifilm in, and others that they won't. So we're really known more for our camera industry. However, cameras are actually quite a small part of our business. And that's because the film industry went into massive decline. So the company decided to invest in a lot of different areas. And one of those areas is the area that I work in, which is the graphics art industry, which accounts for about 10% of the revenue of that company. A little breakdown of the graphic arts, as you can see on the right-hand side. It's split into different technologies. So we've got inks. We're actually manufacturers of inks, not the inks that are in your cartridges that are 3 millilitres and cost £24. We sell them in 5 litre jerry cans. Okay, so our margin is much, much smaller than that. We also make print heads, and I brought one of those so that if anybody wants to see them, they can see what I'm talking about. These companies are a mix of acquisitions that have occurred over the last few years, as well as in-house development of technology. And what the company's trying to do is capitalise on its film industry and convert that over to the new industries. I'm actually part of the integration technology, okay, and that's where we try to bring the print heads, the ink and the systems together to get the best performance out of the combination, to try and create new businesses. And that's my remit as the manager of the Cambridge Engineering Research Facility. So I'm actually a physicist doing engineering, working in an ink company with chemists. So I'm probably the biggest fraud in the room. So I've been with Fujifilm for around about 7 maybe 8 years now, working in the headquarters initially, but I've been in the inkjet industry for nearly 18 years. Okay, so really I'm an inkjet engineer more than anything else. And what I'm going to describe to you is a process where we took Fujifilm technology and we tried to find a new market, and that's printing onto leather. So whenever we take on a new project in Fujifilm, being a very corporate company, we have to understand whether we can actually make a profit in that area. And that's very important to us. We don't do anything, but we can't make a profit. Right? Which means that we have to look at the numbers of any industry. Now, you're probably more familiar with these numbers than us, and in fact, some of you came across to our company to help us to understand these numbers and the requirements of the industry, which we're very grateful for. But we're expanded at the size of the industry, so there are, there you can see, 1.65 billion cows in the world. So we got very excited that we could print on all of those cows and make a lot of money on it. And it doesn't work that way, unfortunately, when it comes to the numbers. What it does help us to understand is the demographics of the industry. So most of those cows are in Asia. So when we're developing inks to print onto leather, we have to make sure that the chemicals we use in those inks are registered in China so that we can export to China and Japan, so we can export to those areas, okay, and we can sell inks into those particular areas. Obviously, not all cows are converted to hide, okay, as you're, again, more familiar. So we went through and worked out what, what the equivalent market would be. And really worldwide, it's an area equivalent to the area of London that's converted to hides, okay, as we understood. Now, we're not a greedy company. We don't want to print on all of those hides and ruin your beautiful leather by making it look very spangly. Right? We just want a small portion of that market. So we're very realistic at the outset that we only want a small fraction. So realistically, we're looking at about 0.1% of that market to print on. And the real aim is to add value to the leather, not to quash the properties of the leather. So things that we've discussed as a company are things when you go to a car dealership, and you sit on a nice settee that's leather and makes you feel good about buying a car, and has those smells that you say associated with good quality, that somewhere on that settee will be the branding of the car dealership in itself. Okay, so it's about highlighting areas, not about saturating areas. When we actually work out those volumes, to us, that's about 1.4 tonnes of ink per year. Okay? And even if you take into account the other sources of leather, that comes out as 1.9 tonnes of ink a year, and our factory generates 24 tonnes a day. Okay, so this is a very, very, very small volume. That doesn't mean to say it's it's 2/24, or 1/12 of our production time, because to make a batch of ink takes a set amount of time, several days. Okay, so it is a commitment from our side, but we're not looking to change the world with this. What it does tell us then is that this is a high value market. There has to be sufficient margin on this ink for us to make a profit, to make it worthwhile as developing the inks. So what we have to do is look further in again, okay, at where that market is split up, and you can see the division here. The value of the leather high market, $8.5 billion. Okay, if you work out from the proportion of footwear within there, and the value of that market, you can work out that 400% added value from the conversion process. So most of the money in the leather market is taking the raw, sorry, I've got to be careful my terminology here, taking the hides and converting them over to a particular commodity. And that's the market that we're in, the conversion process, where you're adding value to the end product. What you've also got to do, though, is have demand. Right? And footwear is obviously a great market for us. Okay, it's one of the biggest markets. We can make potentially more money. And we're seeing online a lot of demand for decorated footwear. Okay, personally, not my favourite style within there. These are actually some of the better styles that I could find online. If you look online, there's a huge range of footwear coming out of China. Some of them very, very gaudy. Okay, this is actually quite restrained by comparison. What they're all doing is exactly the same mistake. They're taking conventional printing inks, printing onto leather and selling them. And that's fine because it's small producers, one-off items, and there's not a big demand. If you were to buy those shoes, right, and wear them for a couple of weeks, you begin to understand that they actually fail. Okay? And we understand this because we try to do it ourselves. Right? But what we've got to do as a company is make sure we have the rigour of going through the entire requirements of a particular product and to make sure it meets the product performance requirements. Now, the reason we have to do that is if we get to mass production and shoes start failing all over the world, it affects our brand. If a one-off artist is making a shoe and selling it to an individual and it fails after a couple of weeks, it's not a big news story. So what we've had to do is work very hard to understand the requirements of the individual products, and actually for inkjet printing, they're very, very challenging. Okay, and I'll explain why as we go through the presentation. Okay, but this means if it's a challenging product to me and it's small volume, it means it's got a high value. So therefore, there's enough margin in it for us to proceed to actually develop the inks. Once we know that there's a market, we have to work out how we're actually going to deliver the product. Okay, so it's okay having a bucket of ink. If you've got nothing to be able to print it on, it's a waste. What I've got here is a graph of the printers that we sell as a company. So we don't actually make printers, but we distribute exclusively. And these are our printers. We actually make inks for a wider number of printers than shown here. In fact, you'd be surprised at where our ink goes. But I can't put those printers on here because of confidentiality. So these are our own printers. When we started this project, of course, we wanted to be able to print for ourselves and to ship the material over to people to convert over into shoes or handbags or whatever. Unfortunately, several of these printers are excluded from use straight away, and they're the roll-to-roll printers, because unfortunately nobody's yet managed to make a cow that produces nice rectangular substrates for us to pass through the roll-to-roll printers. Only in the world of Minecraft does that exist. So we'll have to use flatbed printers, okay, unfortunately. These flatbed printers have a varying productivity. At the high end, okay, so this printer would cost you almost £2 million, okay, within there. It produces 300 square metres an hour, of product, which means 2 machines would print all of the leather in the world in a year. Okay? So it's not commercially the right direction to go in this area. What we really need is these, what we call low-end, and that's not being disrespectful to the printers, it's about productivity. These low-end printers. And their 21 machines would cover all of that leather that we said, that 0.1%. So there's enough variation in there for us to be able to print through different distributors. Okay? So this is with the production rate running flat out. Right? You've got loading time and actual usage. So actually it would be more printers than that, but it's a good example. So we've identified an outlet. That outlet means that this printer has particular characteristics. It's got different productivities, it's got different timings, it's got different print heads and different functionality. So but what it allows us to do is design an ink for that printer specifically. The ink in here would be very different to the ink in here, and that's because of cost. So with these printers, they get through a 5-litre jerry can of ink in about 10 minutes. Okay, this is about a litre of ink. Okay, within there. So the inks that go into here have to be much lower priced than the inks that go into here. Okay, where it's a very cheap ink, we're very restricted on the materials we can use, and therefore we can't achieve the end performance that's required for footwear. With these kinds of systems, the substrate, the material that you print on, is the highest consumable cost. So the price of the ink is actually less sensitive. So it allows us to use a wider range of materials in this type of printer to achieve the functionality that's required. So it's all about finding the balance and finding your market and assessing whether you've got a channel out there. So we've justified the market, we've found the outlet, the printer itself, we need to choose an ink. Okay? Now Fujifilm has a wide range of inks available. The one you're most familiar with, I hope, would be the solvent inks, which are in your desktop printers at home. The solvent in that case being water, but it can be an organic solvent. And they work by applying heat, whether that's top down or bottom up heat, and you end up with a film on the surface after the solvent's evaporated. That film has some very particular properties, okay, but it's only one technology. What we specialise in as a company is UV inks, okay, and that's an ink which is obviously liquid until you apply a UV light, and then it gels immediately. So it's a very, very rapid setting ink, which means you don't have the drying dynamics to take into account. So it's a very high productivity process, and this is the technology that's used right throughout the high street. If you go to your McDonald's and there's the mosaic walls of the patterned walls, the photograph walls, yeah, within that, then this will be this technology. Okay. Now it has some advantages of high productivity, right? But it does have odour, so if you put it on leather, your leather will smell. It's also very brittle, so it's no good for footwear. Likewise, these inks are no good for footwear because they're very chemically sensitive and they don't adhere very well. So they're very delicate films. So there's no good solution for leather, and that's why you've not seen a big uptake in the footwear industry. However, these two have dominated the graphics industry because they're complementary. While there's a weakness in one, there's a strength in the other. So you take your choice through there. What we really wanted, though, was a dream ink. All right, and it doesn't exist. Okay, but this is what we want. If we could produce this, we'd be making more money than all our competitors. What we've actually managed to do is nearly the dream ink. Low productivity is our only penalty, as you can see within that. This is a hybrid UV ink, and this is the way the industry is moving. We're actually breaking the ground on a lot of this, and our competitors are catching up. So we've got a lot of IP in this area, which stops our competitors getting into this field. What it is a UV ink that's dissolved in a solvent ink, which sounds really, really easy. Actually, it's not, because the drying dynamics are very, very complicated. So you dry the film, dry the solvent off, and then you UV cross-link. The big advantage of this technology is this point here. Okay, so when you're inkjet printing these inks, you use oligomers and monomers. The final properties come from a mixture of both, but the monomers are only there really to reduce the viscosity so you can get out the print head. Right? If you print these onto leather, the unreacted monomers can migrate through to the skin and cause irritation. Okay? But what they do, which is even worse, is they actually attack the structure of the leather. And that's why all those shoes that you see online, if they're using UV inks, which they will undoubtedly do because it's high speed, couple of weeks later, they'll begin to crack, okay? And that's because of the monomers. The advantage here is that we're monomer free because we're able to lower the viscosity by using a solvent, and therefore we can inkjet print. And this is very good from a skin contact point of view. So we can use very novel materials in there that don't irritate the skin. Also, it's very low odor. So the final product doesn't smell of the ink, unlike in this case. Just to round the picture, there's a competing technology which we also have, which is called latex inks. So again, you've got spheres of latex and pigment that are dried off in the surface, and then it's heated further. The latex melts and forms a skin over the top surface. Now these are really good inks, and we do exploit those properties of them. However, they're thermally unstable. So if you're making car seat covers, okay, out of this ink, then as it gets hot, then of course they're going to begin to melt. You sit on it, and the ink will transfer to your back. Okay, not very good. So, when we start a project, we've got our technology palette. People say to us, which is best? Well, what we tend to do is we take a two-pronged strategy. Where we can, we try to solve the technology using UV inks because that's the simplest thing to integrate and it's the lowest cost. Where we can't achieve this, we'll then use a hybrid ink. And that's harder to implement, but it allows us to do more, and they tend to be more expensive inks. Okay, but the best way to find out is to actually print and test it. Which sounds simple, okay, but actually is a whole process in itself. And this is my expertise. I work with the chemists and tell them how to change their inks to get through this process. Okay, this is the ejection of droplets where we've taken, it's not quite at the top, we've taken time slots of 2 microseconds in the evolution of a droplet. Okay, and we've photographed it and then we've stitched it all together so you can see how the droplets emerge from the surface. And this is a 6-pulse waveform, so each droplet is initiated by a high voltage pulse on a piezo that causes contraction and pushes the ink out. And you can see we've got a thing called a string of pearls going on here, okay, with it, where you can see the individual pulses ending up. And the droplets travel along that string to the head, and eventually you get break off here. And what you want is this tail to be as short as possible so you don't end up with these satellites. Okay? But this is actually a good example. So you can imagine what a bad example looks like, which is on the right hand side. If you get the waveforms wrong, this is what happens. The droplets curl off and bend. Okay, so you'd end up with gaps in your print and you'd see these streaky lines going through there. And that's all because we've done the waveform wrong and we've ended up with ink on the top of the nozzle plate, and it's pulling the droplets across. So we look at waveform, we also look at chemical compatibility. This is a case shown here of chemical incompatibility where an ink has gone through. This is where, using a Q-Cast head, and I've got one of these that you can see, we got a return from a customer who said, your ink is incompatible. Yeah, and right, it looked incompatible, but when we did the analysis of this, we found it wasn't our pigment that had crashed out. What they tried to use was a competitor's cheaper ink. It crashed out, and then they put our ink back in thinking they wouldn't notice. There's no flamingos. So we've gone through that process, we've chosen our inks, we've engineered them to get them out of the print head in a refined way, and then we're able to print on the surface. And this is our first attempt at printing directly onto leather. And we've got 2 leather substrates. One was a white hide, one was a natural coloured hide. Okay, within there. So the natural coloured hide is this inner, and then the white hide is shown here in the solid. The outer, larger line is our aim. Okay, so if you look at the 3D gamut straight down, that's the outline that you get. And you can see that we're nowhere near the requirements of the ISO standard, so we're too weak on colour. And it's not just a shift because of the substrate colour, there's actually something else going on within there. So we had to investigate as to what was going on when we tried to print directly onto the surface. And what we found was this. So just on a micrograph, when you look at the surface after printing, you can see you've got these very diffuse colour points within there. And no surprise, as the droplet hits the surface, it's absorbed into the surface. Okay? Because our pigments are transparent, so that you can build up a CMYK colour profile and mix the colours, it means that if they're absorbed into a surface, you can no longer see them, therefore the colour is very, very weak. The only solution is to pile more colour on the surface, but then you end up with a very bled out image, and it looks very, very poor from that point as well. So that was a fail on the natural hide. Interestingly, we failed for a different mechanism on the white pie. Okay? So what we did is we printed on the surface, and you imagine you've got a sealed surface, so you don't have the absorption, so you expect things to be good, and the droplet sits on the surface. However, we want to print as fast as possible. So we put many more droplets on the surface. They then coalesce, okay, and through a process of reticulation, so surface energy control, you end up with a lump of ink and visible substrate behind it. Okay, so both processes we don't want. Now, you get around this normally on wide format graphics printers by applying heat, and you can do that on roll-to-roll printers, but you can't do that on flatbed printers because they're very large areas. So to heat that large area uniformly is very difficult, and you lose your registration as you're printing. So heating is not an option with this. So what we had to do was come up with a pinning layer or a precursor layer. Okay, so the precursor layer is a very, very thin layer that we add on the surface by screen printing process, so it doesn't have to be registered in any way. Okay, and then the droplet hits the surface and is absorbed in. And the key to it is to make sure that you engineer it so that you have only just enough film and the interaction is coordinated between the two liquids. Okay, and that takes great skill. I don't hold any, I'm not responsible for that, that's the chemists, okay, within this process. As a company, we started off as a screening company, and we've moved to digital printing for very much the same reasons as in the earlier talk. Our industry disappeared, okay? So we've had to keep reinventing ourselves throughout this. This is nice for us as a technology because it brings two sides of the company together and gives them a joint future. So it's a very nice technology overall. And you can see the end result. You can actually see the individual droplets on the surface, whereas here you've got these lumps of ink which were in the original reticulation process. So now we can create some very nice images, and you can all take a look later on as well. So that's an end result. Okay, so yeah, it's a bit gaudy, you know, because we've got lots of wide format graphic images, and we'd never expected it to be covered that much. But the image is very, very robust. Okay, on there, it has great chemical strength. Right. So people are obviously printing with these technologies or something very, very similar. Okay, but things, sorry, just to show you the improvement in gamut, I'm racing ahead with myself. So you can see the gamut's actually widened out as a result of that, that film on the surface. So that's one thing, we're able to create a very nice image quality. And a lot of companies would draw the line there and go, job done. Okay, we can't do that. All right, what we've got to do is make sure the end product meets all of the requirements. And we do that by looking at different aspects, so things like the flexibility. One big challenge for us was the hydrolysis resistance. Okay, so it's no good somebody wearing a shoe, which looks beautiful until it rains and then the ink falls off. Okay, but it has to withstand the full lifetime of the product. And in the case of a pair of shoes, we're estimating about a year. Okay, myself, my shoes lasted much longer than that, but my wife, you know, a year's about right. So what we did here is we looked at the flexibility of those of the leather that's intended for shoes. Okay, and we looked at it in various combinations. So we've got a pin coat, the ink itself, and then a top coat. And you can see we've gone through those different combinations. We've also tried to beat ourselves. Okay, so we've got our hybrid technology ink, which we think is the best ink for the job. But we tried to develop the best UV ink we could for this application, the most flexible monomer-free ink we could come up with. And we've done a comparison here. Okay, you can see. Then we flexed it immediately after printing. You can see the hybrid ink performs very, very well in all cases. Okay? The UV ink, not so well. We can get 1,000 here and about nearly 20,000 flexes here. The industry requirement is 50,000 flexes. Okay, so the UV ink has failed already. All right. We know it's 50,000 because we're talking to end users about applying this technology, and that's their requirements. So the UV ink is done badly straight away. But we don't just leave it there. The industry requires us to soak it in hot water for not 1, 2, but 3 weeks. Okay, to simulate your boots, if they're football boots being left outside or your shoes being left in a humid environment. So this is a worst case scenario. You can see that the UV inks are backed up now to 1,000 flexes, way below the requirements of the industry. Whereas the hybrid ink, when we've got a top coat, has survived pretty well. Okay. So when we started this out, we had the full combination, okay, of whether to use a pin coat layer, a hybrid or a flexible UV ink, and a top coat. And from the work that we've done, we found that if you use a hybrid ink, then you have to have a pin layer, otherwise you get poor colour. Okay? If you use a UV ink, if you don't use a top coat, then you get very, very poor flexing, way below the industry requirements. So that's a no-go route as well. Okay? With the remaining routes, you can see that we end up with two classifications, either 1,000 flex is available or 90,000 flex is available, which really brings it down to a process selection. So when somebody comes to us now and says, can you print onto leather? Okay, the answer is, what do you want to do with it? You know, if you want to print onto the heels of shoes, then go for the cheap option, okay, of using a UV ink with a top coat layer, because that area of the shoe never flexes. And you'll see actually a lot of shoes do have print, but only in the areas that don't flex. Okay, if you want to have images on the areas of the shoe that flex, then there is only one option, and that's that option there. Okay, and no other company can do this because we've heavily patented. So it's us or nobody in that case. So we've done the ink, we've done the technology, we have to enable people to use it, and we have to show the benefit of using it as well. The people we speak to at the moment are doing printing onto shoes, but it's using screen printing processes. So they've got a set of equipment as shown here. Okay? And they say the biggest problem they have is shrinkage between applications of colour on their screens. You have to dry every screen application, which means that you get a slight amount of shrinkage, which means your next screen has to take that into account. So really the wastage in this area is very, very high. Most of this work goes on in China, okay? And although we've said it's 5 screens, normally it's more than 10, and typically it's 27 screens. So only one of those screens has got to go wrong for the whole footwear to be wasted. Okay? What you can do with inkjet printing is you can get away with those registration steps. So you're printing all the colours simultaneously, and you don't have to register your screens. So your yield goes up. And I can't tell you which footwear manufacturer, but one footwear manufacturer that we're talking to is so keen about this because they reckon it'll save them 85% of their printing costs per year. Okay? So they're not interested in the intricacies of the designs or anything like that. They're just interested in the money saving that inkjet printing can give them. And for us, that's the real value. So we're not trying to eat into traditional markets, we're trying to add extra value. So for ease of adoption, we've made it easy. We've looked at the whole process. And we've enabled it by creating the materials that people need to complete the entire process, but also we've enabled it with equipment that's ready off the shelf that they can start to develop their products around. And that's what we do as a company. So we identify markets, leather being one of them, where we can add some value with a high quality material. And as a company, we pride ourselves on going for the difficult markets, looking at technologies which are technically demanding that others can't get into. It gives us a bit of exclusivity, and it means we can get an heirloom and put lots of patents to protect our technology so that people need to wear it. However, we're not about exploitation. There's no point us making an ink that's really good that nobody can afford to use. So we're very, very realistic about what we can do, and we work with partners, and that's the main thing. We work with partners, that's end users, industry experts, and OEMs to make sure that we're delivering a product that meets the industry requirements, okay, but also enables us to make a few quid so we can carry on and make new products as time goes on. Okay. Any questions?
Yes.